Okay. Arcs and chords. All right. If you remember, chord goes from one side of a circle to the other. Okay, there we have a circle. First of all, let's talk about congruent chords. So, let's say I'm going to make a chord that is 1 inch. So AB is congruent to what? CD. What do you think? What else do you think would be true if you were just guessing? Looking at that picture, knowing that I measured that out properly. Think you could say anything else? And think about the name of this section, arcs and chords. So what am I comparing? Arcs and chords. So what do you think? So I said this is congruent to that, right? Then what? What'd you say? Very good. That arc's congruent to that arc. Okay? Whatever the measure of that arc is, we don't know what it is. Whatever it is, they're the same. Because why? The chords were the same. Now, what do you think is going to be, when I say vice versa, what do I mean? If chord AB, or I'm sorry, if arc AB is congruent to arc CD, then what do you think you can say about the chords that contain them? Then the other way around, right? Let's write this down. So as you would imagine, we will have some things we'll do with that. Okay, draw yourself a second circle. If a diameter is perpendicular to another chord, then the diameter bisects that chord. So what do we think that means? Basically, draw yourself any chord. We'll call that chord AB. What does this say? If you've got a chord, and then you have a diameter that's what? Perpendicular. What does that word mean? What does it mean when two segments are perpendicular? Huh? They intersect, that's part of it, but that's not really what makes it perpendicular. Yeah, exactly. When they cross, they make a 90-degree angle. So what I'm saying is if any diameter, see this is a diameter right here. Everyone agree? Does that cut that in half? That chord in half? Obviously not. But obviously, is that a right angle? This angle created here? Of course, I'm talking about the edge of my ruler and this chord I just drew. Is that a 90-degree angle? No. This is a little closer to a 90-degree angle, but is it a 90-degree angle? And does it cut it in half? Everyone look up here. Am I getting closer to a 90-degree angle? Huh? Yes. But it doesn't cut it in half, though. It's not there yet. As I get closer, not quite there yet. How about right there? Is that a 90-degree angle? What does it do? What does it look like it does, at least? What does this look like it is? So do you see how if that diameter, once it gets to 90 degrees, it does what to this chord? Cuts it in what? Half. So your if, the things that have to happen, one, it has to be a what? Diameter. And what? What? Perpendicular. As a result, what does it do? If it's a diameter and perpendicular, then what happens? It bisects the chord. Remember when it wasn't perpendicular, it was a diameter. Now I could draw something perpendicular to it, but is this a diameter? Huh? See, I can have one true, but that doesn't mean that it cuts it in half. As you can see, that's not a diameter. So it is perpendicular to it, but it doesn't cut it in half. The only one that cuts it in half is the chord that's a diameter and perpendicular to the chord. As a result, cuts it in half. Okay? Vice versa is also true here. It says the perpendicular bisector of a chord is a diameter. Well, that's the vice versa of it, but you got to kind of see the significance here. Let's say I didn't know where the center was, and I drew a chord. if I was able to construct a perpendicular bisector of this, it would have to go through the center. So what this is saying is if this is perpendicular and it cuts a chord in half, then this has to be a what? Diameter. So isn't it just the opposite? Here it says if it's a diameter and it's perpendicular, it has to what? Cut that in half. Here if it says it's perpendicular and it cuts it in half, then it must be a what? Diameter. Which is handy if you're trying to figure out, well, does this line go through the center of the circle? You know it does. Believe it or not, this is how you could find the center of a circle in real life. Okay? You could basically, let's say you had a circle. You could basically put out a string, measure it, go right to the middle, use something to make sure you're 90 degrees, and you know this line has to go through the what? Center. So you measure from one side to the other, cut it in half, and you know that's the what? Center of the circle. You could actually physically find, that's how you find the center. Because once you know you're on a diameter, it's just a matter of getting the distance from here to here, and then cutting it in what? Half. But you know, you could easily accidentally draw your line right here, and in real life it'd be kind of tough to tell. So this is something that's used for things like that. This section is a lot of theorems and a lot of things to apply. This next one sometimes people struggle with. So I'll preface it with this. Do you guys remember when I'm finding the distance, and don't draw this, when I'm finding the distance from a point to a line, how do I find that distance? If I want to know the distance from this point to this line, how do I find it? Here's an easy way to think of this. If you had a plane flying, how do they tell what the altitude is? They measure it what? Do they measure it back here to where it started flying? Do they measure it to here? Where do they measure it? In your own words, what could you tell me? Well, I mean, I could draw a bunch of lines to measure here, right? At what point, how do I know how high the plane's flying? I measure it what? Straight down. That's actually what I was looking for, straight down. What is straight down in geometry? What does it create? Anybody? 90-degree angle. So so the moral of this story is basically this. Anytime I'm going to ask you, okay, what is the distance from a point to a line, it's always going to be that what kind of distance? Perpendicular distance. You always measure it along a right angle. That is something we have talked about before, but it's something usually I always have to remind here. So, you've got a circle. Okay? If two chords are equidistant from the center of the circle, then they are congruent chords. No matter how I draw these two, if I draw two congruent chords, okay? What is this saying? If two chords are equidistant from the center, how am I going to measure this distance from the center? From a point to a line. What am I going to do? Have to measure it along a what? Right angle. What does it look like these two segments I'm drawing are? What do you think I can say? First of all, this would have to be a what? Right angle. So if EF is congruent to what? E what? Then what? AB has to be congruent to what? CD. And since this is perpendicular and coming from the center, what does it also do to this side? Cuts it in half. You think you can do the vice versa of that? What would that be? If AB is congruent to what? CD, then what has to happen? EF has to be congruent to what? I know that's a lot of information. But those are the tools you're going to use for the problems today. You have a lot of different things you can do. They can make about every type of problem in the book with this. Why? Everybody look right here. What happened when I can just decide to connect the dots right there? Anybody tell me what I have? Huh? I have a right triangle. This is the what of the circle? Is it not the radius of the circle? See how there's all kinds of different things? Do you think they won't, and don't write this down, do you think they won't connect the dots here to where that's a radius, that's a diameter, that's perpendicular, you know that cuts that in half? They could give you this and ask you to find that. You do Pythagorean's theorem, right? They could give you this angle, this, ask you to use trig functions to find that. You know, all kinds of different things, couldn't they? Looks like a lot of fun, huh? Has everybody got that down? So you got your workbooks. Find the value of x in each circle. How many theorems, basically things did I give you? We had, what, in essence, 3 things, but 2 of them you had the vice versa, right? Or all of them you had a vice versa, so in essence 6 things. You can go either way, right? But there's 3 main things. Does this deal with the first thing, second thing, or third thing we talked about? What's the first thing we talked about? Anybody? Okay. If the chords are congruent, then what? The arcs are congruent, and vice versa. Does this deal with that? Yep, that's what they're wanting you to refer to know. These two chords, they are telling you are congruent by saying they're the same measure. So what do their arcs have to be? If this is congruent, then this arc is congruent to this arc, meaning that x has to equal what? 79 degrees. Right here, that's the first one still. If this chord is congruent to this one, which they are indicating by saying they are both 14, then what do we know about the arcs? They have to be what? Congruent. So, does it look like an algebra problem? What do I probably need to create? An equation, correct? What's my equation? X plus 17 must equal what? Subtract x, subtract 2, subtract 2. 3x is equal to 15. Divide both sides by 3. X is equal to what? If this arc is congruent to this arc, what do I know about these chords? Huh? So what's my equation? 2x minus 12 is equal to what? That's easy, isn't it? What about this one over here? How are they trying to confuse me? First of all, this chord, just because they meet, does not mean that it's not a chord. They still go from one end to the other, correct? The chords are congruent. So what arcs are congruent? This arc is congruent to what? That arc. However, how am I going to find the measure of x? Everybody look up here. When it comes to arcs, what do we know for sure? What's the measure of this arc I'm about to draw right now? What's the measure of that arc right there? 360. What's left for all of this to be after I take away the 38? 360 minus 38, what do I get? Huh? 322 degrees. Well, if this is congruent to this, then all I have to do is do what to 322? What's the answer? Okay. Right here. This arc's 67, this arc's what? 67. If those chords are congruent, what's this central angle? The central angle and its arc are the same, so what's x equal to? 67? Not so bad, is it? One other thing I think I forgot to mention on the one where we've got this one perpendicular right here, if you extend this, if it cuts this in half, what do you think it does to this arc? Cuts it in half. Okay? I'll tell you what, I'll do some examples from your homework. Once again, if everyone would change the 8-3 to 10-3, I'd appreciate it. You think there's any chance that I'm okay with you not showing your work on this? No. On problems that have more than one step, you just write x equals 2. I'm gonna have problems with it. And to be honest, I don't see anything wrong with writing, if you got x by subtracting something, why not write it on there? Prove to me you know what you're doing. That's the whole idea. Express to me what you're thinking. The fact that you understand the material. first. Change that to 10-3, please. What am I going to do on number 1? Let me let you in on a little secret. They're going to add more information than you need sometimes. They gave you from here to here, right? Do you know what here to here has to be? Anybody? 18.4. Because that's the center and that's a radius, right? So what would x be? 18.4 minus what? Huh? What do you get as an answer? Huh? 130? What? I can't. I still can't hear.
0.8.
Thank you. You done? Now, here, this is the, when they put it right in the middle right here, what do you think they're saying is 23.6? Each piece or the whole thing? The whole thing. Okay? Right here. What do you think, what theorem do you think you're going to have to use for this one? If you cover everything else up about this problem, what kind of problem is that? It's a right triangle where they gave you what? 2 of the 3 sides. Do you know how to find the third? Use what? Huh? Crop, what do you use? Right. Pythagorean theorem. Which one's your hypotenuse? Louder? 20.6. And these are your 2 legs. So x squared plus 18.2 squared is equal to 20.6 squared. Okay? Flip the page. What do I know here? If this is perpendicular to this line, what do I know it does? If it goes through the center and it's perpendicular to a chord, what does it do to that chord? Huh? That's congruent to that. So if that's 15.3, what's this? 15.3. Is this a diameter? Really, no one in this class can tell me if here to here is a diameter? Yes. So what is this piece from here to here? That's a radius. What is it? It's going to be what? 34.6 divided by what? 2, which is what? 17.3? Now that I've used those theorems to get where I need, is that not just a... What type of problem is that? One we just did? I have a right triangle, I know 2 of the 3 sides. What theorem am I going to use? Wow. Common theme here, huh? My gosh, look at this one. 6.3, 10.1. What's x? Anybody? 16.4. Why? Sam, what do you think? Why is it 16.4?
You add 6.3 to 10.1.
Right. Now, if you're confused about what they're referring to, don't they have the 6.3 a lot closer to this part than this one? They're centering it up here. So they're talking about this length, 6.3, this length's 10.1. Is this a radius? Does it go from the outside to the center? Is the radius the same no matter where you draw it on a circle? So if this is 16.3, what's this gonna be? Not too terrible, is it? Bunch of problems like that, huh? On the top of your paper, from the book, I want you to do these problems. Number 7, 10. And you'll staple it to the back of this. (31) and 32. That's all. Just 4 more problems. All I ask is that you show all steps and work. You don't have to draw the figure. So write that on your deal.